Okay, let's look at the last little bit of our periodic table now that we've defined what the periods and the groups are and how that relates to its electron configuration, and start talking about how knowing where things are positioned in the periodic table and how things change from left to right will allow us to have a huge amount of information at our fingertips, remembering that you always get a copy of the periodic table every time you're going to have a test or an exam on chemistry from here on in. So the periodic table shows what we call trends, okay? This is a repeating pattern that tends to repeat every 8 elements. Okay, so we tend to see every 8 elements, we tend to see a repeating pattern in the properties. And if you remember, this is because we could have 8 electrons, so we went 2, 8, 8, and then 2. Okay, so because elements like to complete their octet, okay, then that means that once they have 8 electrons in the valence shell, okay, 8 electrons in the valence shell, they're very stable. So what happens is we see this repeating pattern as atoms become more and more stable, getting to 8 electrons, okay, remembering that our noble gases, these group 18 noble gases, all have 8 electrons in their valence shell, which makes them very, very stable. So as we move across the periodic table from left to right or up and down the group across a period or up and down a group, okay, then we see different patterns that emerge. And if we remember what some of these patterns are, it helps us to understand how things might behave. So you might remember that we said all of these elements to the left and then over to our little staircase over here were metals. So what that means is that, and then we hit non-metals here. So as we move from left to right across the periodic table, what we refer to as metallic character, so the things that make a metal, decrease. Okay, so from left to right, our metallic character decreases. Okay, so things over on this side over here on the left are more metallic than things on the right. Okay, and that makes sense because these ones over here are all non-metals, so they're not even metallic at all. So we go from very metallic to not metallic. Okay, and so that is, they decrease in metallic character as we go from left to right. But as we go down a group, it gets more metallic. Our metallic character increases, making this guy here, which is actually francium, one of the most metallic elements, okay? And metals tend to be defined by their ability to lose an electron, because that's how metals react. So francium is one of our most reactive metals, so the reactivity increases as we go down that group as well. Another thing to remember is that our atomic radius, okay, so that's how big the atom is, okay, the atomic radius, how big its electron cloud is, increases as we go down a group, okay, as we go down a group it gets larger, and that makes sense because we keep adding shells on, and as we add a shell we add another layer, like a layer to an onion. Okay, and it is biggest on the left-hand side, so atomic radius decreases as we move from left to right, which means that the atoms on the right-hand side of the periodic table are going to be much, much smaller than the ones on the left-hand side of the periodic table. Okay, so you'll see lots of diagrams like this on the internet where the head of the arrow points towards the highest value or the direction of the increasing trend. Okay, so we have trends that talk about atomic radius, metallic character, reactivity, and things like that. So the more we learn about these trends, and some of them are outlined in your textbook, the more we can understand about the elements in the periodic table. For us in year 10, atomic radius is a really important one. Okay, so in our periodic table, fluorine is over here, so ones on the right hand side are going to be small, and ones down here on the bottom of the left hand side are going to be large. Okay, so there are a couple of trends for us to remember: metallic character and atomic radius. So we can start to predict, will it be a metal? Will it be a non-metal? What type of bonding will it form? And we'll talk a little bit more about bonding as we move through this topic. Okay, but it's important to remember, and we've talked about bonding a little bit before in the past in year 9, that chemical bonds are made through the movement of electrons. So the type of bonding that we see is dependent on the valence electrons. And remember, we can always find out how many valence electrons an atom has by looking at their position in the periodic table. So bonds can be made either through the transfer, so the loss or gain of electrons making ions, which is ionic bonding, or the sharing of electrons, which is covalent bonding. Okay, and these ones, covalent bonding is going to be in nonmetals. Those ones on the right hand side. Of the periodic table, and ionic bonding is between nonmetals and metals. So you would have something from the left hand side reacting with something from the right hand side. Okay, but regardless of whether it's ionic or covalent, or the third one, metallic, which occurs only between metals, okay, regardless of what type of bonding it is, it's always occurring due to the attraction between a positive and a negative particle. Okay, so we just have to identify what that positive and negative particle is. Is it ions? Is it the attraction between two nuclei sharing electrons? Or is it with metals, the cations and the delocalized electrons? But the type of bonding that something has always tells us a lot about the properties that that material will have. So it's really important to use our periodic table to be able to work out if things are metals or non-metals, and then predict what type of bonding they will have so we can predict what type of properties the material will have. So this is a summary of the type of bonds that we are going to look at in year 10, and you probably will have seen before. So we have metallic bonds, which are always between two metals. Okay, in any piece of metal you have metallic bonding. Okay, it's the only type of bonding that we see in a pure metal substance. We have covalent bonding, which is a non-metal to non-metal interaction, and we have ionic bonding, which is between a metal and a non-metal. One way I find to remember this is using sort of like a Punnett square that we see in genetics. Okay, but this time what we're combining is our two options are a metal or a non-metal element. And the other option we have is it can be a metal or a non-metal element. So these act sort of like the alleles in our genetic cross. And when we do this, if we combine a metal with a metal, we will have metallic bonding. If we combine a metal with a non-metal, then this will be ionic. So down here we have a non-metal and a metal. This will be ionic bonding. Then the only time that we can have covalent is when it is non-metal to non-metal. So I suggest you write this in your notes. It's a really quick and easy way to figure out what type of bonding that we have, as long as we can figure out where on the periodic table something is, to if it's a non-metal over on the right hand side, or a metal, or a combination of both. Okay, I'll see you in class.